Welcome. In this video, we're going to be talking about square root graphs, which corresponds to exercise 4C. So once we've gone through all the notes, you're going to begin work on exercise 4C. Just as we did when we were talking about truncus and a hyperbola, we're going to begin by filling out a table of values to help us appreciate the shape of a square root graph. Before we fill out a table of values, we need to know what the rule of a square root graph is. And here it's written, the graph y is equal to the square root of x, or to say it another way, y is equal to x to the power of a half, because we know that a square root is the same as to the power of a half. Don't worry too much about this notation. We'll talk more about this as we go further along in methods. As long as you know that the square root of x is the square root graph, that's all you really need to know. And there's also this to it as well, for x is greater than or equal to 0. Now, the reason why we have to say this is because you can't square root a negative number. You can square root 0, you can square root positive numbers, you can't square root a negative number. So that's why we've written this right here. All right, let's now begin filling out this table of values. We're going to begin by writing out what our rule is, y is equal to the square root of x. And then what we're going to do to figure out what our y values are is we're just going to sub in our x values. So I'm going to put a 0 into my x spot here. And what am I going to get out? I'm going to get 0 out. So that means 0 is my y value. So my y is equal to 0 here. Then we keep on going. I'm going to sub 1 into my x spot next. And if we do that, what's the square root of 1? It's just 1. So I put a 1 there. Next, I've chosen 4 to sub in. Of course, you can square root 2 and 3, but I think you can see why I've chosen 4 here. It's because it comes out with a nice number. The square root of 4 is 2. So that is going to be there. Then I'm going to sub 16 into my x spot. What's the square root of 16? It's 4. And hopefully you can see what's happening here. I'm just square rooting all these numbers. The square root of 25 will be 5, and the square root of 36 will be 6. And that's how it works. We've filled out our table of values now, and now I can plot these points and see what my graph looks like. So here is the point 1, 1, and we've plotted it right there. So there's 1 there. Then we're going to plot the point 4, 2. So here is 4, and then over here would be 2. So there's the point right there. And then let's plot the point 16, 4. Let's say, I don't know, it would be all the way over here, wouldn't it? All the way over there, 16, and then a y value of 4. So this would be 16, 4. And you can see what our graph looks like. It looks like this. And that is the shape of a square root graph. So it's really, really important that as soon as you see a rule that looks like this, you know that it looks like a graph like this. That's what you need to know. The next thing we need to talk about is that the graph of y is equal to the square root of x corresponds to the upper part of the graph shown, meaning it corresponds to this upper branch of the graph. And the reason why we have to be specific about this is because it is one arm of the parabola x is equal to y squared. So if we look at x is equal to y squared, we're not used to, x being the subject here. So let's make y the subject by square rooting both sides to get rid of this squared here. And if we were to do that, if we were to square root both sides, I would end up with y is equal to plus or minus the square root of x, because I'm just square rooting both sides there. And now because I've got plus and minus, I've got two branches of this graph. So the plus side of it, so this is the plus side of it, corresponds to this. And then the minus side of it corresponds to down here. So do you see how when I've got a minus in front of the square root graph, it's the bottom part. When I have a plus, it's the top part. Now you're only ever going to be asked to graph one branch of it. You're not going to graph two. And as we go through some examples, you'll see what this means. So don't get too daunted by this quite yet. All right, let's now look at our general form, just as we had a general form for the truncus and the hyperbola, so too for the square root graph. So what is our general form? So we have an a here, and this a tells us our dilations. We have our h value, and the h is underneath the square root sign, so that's telling us the horizontal translations. And we have the k value here, and the k value tells us our vertical translations. Importantly, the coordinates hk equal the endpoint of the square root graph, and as we come to sketch them, you'll see what the endpoint means. All the graphs of this form will have the same square root curve shape. So what we've seen above, they're all going to have a shape that looks like this. Note that the endpoint of the square root graph is included and should be shown with a closed circle. We'll be speaking more about the endpoint very soon. let's, before we start sketching, just talk about what some transformations would look like. Let's begin with this. So consider the graphs y is equal to this right here. All right, let's slowly work our way through this. So it says for y is equal to 3 the square root of x minus 1, the graph of y is equal to the square root of x has been dilated by a factor of 3. So this 3 at the front here causes a dilation by a factor of 3. And what that means, if you compare it to y is equal to the square root of x, we've just dilated it up. We've pushed it up. We've stretched it, if you can imagine, away from that x-axis. So that's what's happened there. Then we keep on reading, and it has been translated horizontally plus 1. And that's because we've got a minus 1 underneath our square root graph. So just as when we're transforming a quadratic parabola, so when we've got a parabola and we're moving it left and right, so if I was just come over here, you don't have to write this down, but let's for a second think about this. If I had y is equal to x minus 1 squared, we know what that looks like. That looks like this. And this would be the point 1, 0. So the negative 1 has moved it to the right. And that same logic applies over here. So when we've got a negative, it moves it to the right. If it was a positive, it would move it to the left. Then we can also talk about our endpoint here. This thing right here, where it ends, is, shocker, the endpoint. And the coordinates of this would be 1, 0. And you always have to make sure that you're labeling your endpoint. And with the coordinates. So make sure you're labeling the endpoint with coordinates. So 1, 0. And that's our next sentence here. It says the endpoint of the square root curve is at 1, 0. Perfect. That's what you need to be thinking of when you're doing this. Let's now move on to the next one here and see what's going on. So we've got y is equal to negative 2 the square root of x minus 1 plus 4. All right. So for this, the graph of y is equal to the square root of x, so that's just our blue graph here, has been dilated by a factor of 2. And that's because we've got this 2 out the front. And remember, that's just like causing the stretching to be a bit different. We've stretched out a bit. Then the important thing that I really want to draw your attention to is that it's been reflected in the x-axis. And that's because you've got a negative out the front here. So remember, when you've got a negative in front of the square root graph, that means you're considering the bottom half of it. So remember when we were up here, when you got a negative in front of the square root, you're considering the bottom half of it. And as you can see here, we've got the bottom half of this square root graph. The next thing that we need to talk about is the different translations that have occurred here. So it's been translated horizontally plus 1. That's because you've got a minus 1 there, no surprises. And then, now I think I'm running out of colors, so I'm gonna have to go to yellow. Vertically plus 4. And that's because you've got a plus 4 there. Once we've moved it all around here, what you can see is that my endpoint is going to be here, and my endpoint is going to be 1, 4. Now, when we're talking about vertical translations, it's exactly the same as when we're dealing with quadratics, so a parabola. So for instance, if I was to come over here and I had y is equal to x minus 1 squared plus 4, I know that that means that I've moved it 1 to the right because I've got this, and 4 up. So it's going to look something like that. It's a pretty ugly looking parabola, but you get it. So those things still apply, where like when it's negative, you move it to the right. If it's positive, you move it to the left. So just be aware of that when you're working through this. All right. I'll make this the first part. In the next part of the video, we'll go through some sketching. So make sure you click on the next video to see some sketching. Hopefully all this made sense, and I'll see you in the next part.